Okay, in this video, we're going to be talking about rate of change. Rate of change is slope, but it really describes the relationship between two quantities that are changing. We do identify it as the vertical change over the horizontal change, but because there are quantities, we think about it as the change in the dependent variable, which is y, over the change in the independent variable. If you look at this example has a graph about a motorcycle rise. The dependent variable is the distance in meters, and the time is the independent variable. And so again, we're taking the change of y, which is the dependent variable, over the change in x, which is the independent variable. Okay, so we want to do two things. We do want to find the slope, but we also need to explain the meaning. On these graphs, if you notice, they're not counting by 1. So instead of saying it's going up 1 over 1, we need to think about the points that are on this graph, okay? So in this one right here, this point, if we find any point where it crosses evenly, this would be the point 20, 40. So at 20 seconds, there is a distance of 40 meters. And this next point, I could use this one. I could also use this one right here at the beginning, but none of the other ones cross evenly. So if I was to use this point, we have 40, 800. And so at 40 seconds, 800 meters has been traveled. So we're going to find the change in y. Okay, so you can use the slope formula, which is what I would actually recommend. This is going to be x1 and y1, and x2 and y2 if we think about the points going from left to right. This is the first point, this is the second point. And so if I plug those into the formula, y2 minus y1 would be 800 minus 400. And then it would be 40 minus 20. Okay, if I was to simplify that, you get 400 over 20, and that simplifies into 20 over 1. And we actually do want to use both the 20 and the 1 in this instance because we want to describe what's happening to the dependent variable on top and the independent variable on bottom. So, since it's positive, it means it is increasing. It's increasing 20. And what unit is the y? Well, the unit here is meters, so it's increasing 20 meters every 1, and I need to use the unit for the x-axis, which is second. Okay, so this motorcycle is increasing 20 meters every second, according to this graph. If we look at this next one, it is decreasing. It's a negative slope. Okay, so anything negative is going to indicate a decreasing amount. This graph is about a tank of gas. The y value that is the dependent. It means the gallons that are in the tank are dependent on how many miles have been traveled. Okay, and if you notice this one right here, on the y-axis, the first number is 5 and then 10. So you might think it's counting by 5s, but if you notice there's a line right here, so it's actually going to be halfway between 0 and 5, which is 2.5. So this y-axis is actually counting by 2.5. And again, on the x-axis, we have 100 as the first number, but there is a mark, so really this one is counting by 50. Now, I recommend using points here. So this one right here would be the point 0, 15, and this would be the point 155. And so what this really means is 0, at the starting time, there are 15 gallons in the tank of gas. And then after 150 miles traveled, there are only 5 gallons left. Okay, so the gallons are decreasing. So again, if I use my slope formula from left to right, this is my first point. And so if I just plug those into the slope formula, I'm going to have 5 minus 15 in the numerator and 150 minus 0 in the denominator. So that's going to give me negative 10 over 150, and that is going to simplify to negative 1 over 150, and we want to leave it as a fraction. Okay, this negative means it's decreasing. So the tank of gas is decreasing 1, and what is the unit for the Y? The unit is gallons, so it's decreasing 1 gallon for every 150, and this is the X, so the unit here is miles. So the tank is decreasing 1 gallon for every 150 miles traveled.